Imagine this. You wake up in a remote wooden house deep inside a Siberian forest. No traffic, no factories, just trees, silence, and the slow sound of a river. And then, without warning, the sky becomes brighter than the sun. A wave of heat slams into you. The windows explode inward. The ground shakes as if something gigantic has just landed. But when the dust settles, there is no crater, no fallen star, just a forest flattened in every direction. This is not science fiction. This is the Tunguska Event of 1908. Welcome to today's episode, the day the sky exploded over Siberia. On the morning of June 30th, 1908, at around 7:14 a.m., an enormous explosion tore through the atmosphere above central Siberia near the Podkamennaya Tunguska River. The blast occurred high in the air, roughly 5 to 10 kilometers above the ground, and yet it devastated a huge area below. What makes Tunguska unforgettable is not just the scale of the destruction, it's the mystery. No confirmed impact crater, tiny fragments at best, and over 2,000 square kilometers of forest knocked flat, as if a giant invisible hand had swept across the land. So what really happened that morning? A comet? An asteroid? Something else entirely? Let's walk through the evidence, the eyewitnesses, and the theories that still divide scientists today. Chapter 1. The Place the World Forgot. To understand Tunguska, start with where it happened. Central Siberia. Remote, harsh, largely empty, especially in 1908. This was not an age of instant news, satellites, or rapid international response. If something happened out there, it stayed a rumor for years. The region near the Podkamennaya Tunguska River was a vast stretch of taiga, dense forest, swampy ground, and very few people. That isolation meant two things: few direct witnesses, and a long delay before any serious scientific investigation could even begin. In a way, Tunguska gave Earth a lucky test run, a colossal blast in one of the least populated places on the planet. Chapter 2. The Morning the Sky Blew Apart. So what actually happened that morning? According to later analysis, the explosion in the atmosphere released energy estimated at up to about 15 megatons of TNT, hundreds of times more powerful than the atomic bomb dropped on Hiroshima. The shockwave flattened around 2,000 square kilometers of forest, and about 100 square kilometers of pine forest were left charred. Eyewitnesses, some living tens of kilometers away, reported seeing a blazing fireball streaking across the sky. There are accounts of a flash so bright that people felt they could read a newspaper by its light, followed by a wave of heat and a thunderous series of blasts. The air itself became a weapon. Windows shattered, people were thrown off their feet, and houses shook. The force didn't just stay local. Seismographs in places as far away as Western Europe recorded the shockwaves. The blast was initially visible from roughly 800 kilometers away. One event, in a remote corner of Siberia, and the Earth's instruments, far away, still picked it up. Chapter 3. The Forest That Fell Like Grass. The strangest part was not just the power, it was the pattern. Nearly 20 years later, in the late 1920s, Soviet scientist Leonid Kulik led the first major scientific expeditions into the Tunguska region. What his team found was surreal. Around the epicenter, trees were stripped of branches and splintered. For 15 to 30 kilometers around, millions of trees lay on the ground, all pointing away from a central point, like rays on a diagram. From above, decades later in aerial photos, you can see the effect clearly. A radial pattern, as if a stone had been dropped into the forest and the trees were waves. But when the expedition reached ground zero, they did not find what they expected. No giant crater. Instead, they found a marshy bog near the epicenter. Think about that visual. A ring of devastation, scorched and flattened, and in the center, not a yawning hole, but wet, uneven ground. It looked like something had exploded in the air, unleashing its fury downward, then vanished. Chapter 4. Witnesses of Fire and Wind. Eyewitness testimonies, collected years later, add more texture to the story. People described a column of fire on the horizon, followed by a shockwave that shattered glass and knocked them down. Some reported feeling intense heat on their skin, as if standing too close to a massive bonfire. Others spoke of a noise like artillery fire rolling over the land in multiple booms. One of the eerie side effects came not from Siberia itself, but from the night skies over Europe. In the days after the explosion, observers reported unusually bright night skies and strange atmospheric effects. People talked about being able to read at midnight without lamps, under luminous clouds high in the atmosphere. These knocked-lucent clouds became a major clue. They hinted that something had thrown an enormous amount of material, possibly including water vapor or dust, into the upper layers of the atmosphere. An explosion in one remote forest, and the sky thousands of kilometers away started behaving strangely.
Chapter 5. Comet or asteroid? So what caused it? Over the decades, two main scientific camps have formed, and Britannica neatly outlines both. The first camp argues for a comet. A comet is rich in ice, dust, and volatile materials. Scientists in this camp point to those bright noctilucent clouds after the event, suggesting that a comet entering the atmosphere could rapidly vaporize, injecting large amounts of water and particles into the upper atmosphere. In this view, the Tunguska object never reached the ground as a solid block. It disintegrated explosively in the air, creating a massive airburst that leveled the forest and caused distant atmospheric effects. The second camp favors a stony or carbonaceous asteroid, essentially a large meteoroid. According to this interpretation, the Tunguska object might have been about 50 to 100 meters in diameter. Objects of this size are estimated to collide with Earth on the order of once every few hundred years. In this scenario, the asteroid plunges into the atmosphere at high speed. As it encounters denser air, pressure and heat build up. Eventually, the object catastrophically breaks apart and explodes before reaching the ground, releasing immense energy in a fraction of a second. Here's the key. Both sides agree on the basic idea of an airburst. The argument is over the type of object and the details of how it behaved. Why so much debate? Because physical clues are limited. Investigators have found only minute probable remains, tiny fragments less than a millimeter across, no big chunks of rock, no obvious comet nucleus. Tunguska leaves us with just enough evidence to be confident something big happened, and just little enough to keep us arguing about exactly what it was. Chapter 6. What Tunguska Teaches Us. 3 minutes. Tunguska isn't just a historical curiosity. It's a warning and a case study. First, it shows how dangerous an airburst can be. You don't need an impact crater to cause catastrophic regional damage. An object exploding at altitude can unleash a shockwave powerful enough to planet forests, damage buildings, and injure people over a wide area. Second, it underlines how lucky humanity was this time. If the same object had exploded over a major city instead of a remote Siberian forest, the casualty numbers would have been unimaginably higher. And third, it pushes planetary defense scientists to refine models of near-Earth objects, their sizes, their paths, and how often they might hit. An event that likely involved an object only tens of meters wide became one of the defining impact events of modern history. Rare, in astronomical terms, does not mean never. It just means not yet. Outro, 45 to 60 seconds with subscribe CTA. So what really happened over Tunguska in 1908? The most accepted picture today is a large space rock, or possibly a comet, entering Earth's atmosphere, exploding mid-air with the force of a massive nuclear weapon, and erasing itself almost completely in the process. No crater, no easy answers. Just a flattened forest, strange night skies, and a puzzle that still pulls scientists back more than a century later. In the next episode, we'll stay in the world of extraordinary historical incidents. One event, one timeline, one central mystery that changed how we see the world. If you want more deep dive stories like this, remember to like this video, subscribe to the channel, and turn on notifications so you don't miss the next episode. Thank you for watching, and see you in the next chapter of history.